right, you guys, I know you're super excited to know that learning about natural logarithms is our very last topic of the school year. So after this, it's all downhill from here. Reviewing, testing, finals, but no new content after today. So natural logarithms are really a logarithm with a base of e. And you're like, E is a letter, but it's really not in mathematics. E is a number, and that number is 2.71828, and it goes on and on and on and on and on. It's used in a lot of science and mathematics. It's an irrational number, just like pi. You know, pi goes on forever. The number e goes on forever. So if I write it log base e of x, on my calculator, I have two options, right? Log, fill in the blank, and the regular log button on the calculator. But remember, the log button on the calculator has a base of 10. So how do I take into account logarithms with a base of e? If you notice on your calculator, there's an ln button here. Using that button gives you a base of e. And then notice how right above it, so if I need like the natural log of 5, I get a decimal. Right above it is an e to the whatever. So if I had like e to the first, you could see it's 2.718281828, and it keeps going and going and going on forever. Okay? So you can write it log base e of x, but if you use this button on the calculator, the natural log button, and your scientific ones have it also, you'll save yourself some time. So the number e is the base for natural logarithms. Like we had common logs, base of 10. Natural logs have a base of e. And it's abbreviated ln. And then all of the properties that you know about logs, the condensing, the expanding, the addition goes with multiplication, subtraction goes with division. All of those rules apply to natural logs as well. But the biggest rule you need to know about natural logs is that the ln of e is equal to 1. And when we're solving our equations, that will cancel out. All right, so let's just practice converting logs to exponentials and exponentials to logs. Okay, if I want e to the x equals 9, you could write it log base e of 9 equals x. Remember that if we had log base b of y equals x, then y equals b to the x, logarithm to exponential, exponential to log. But a log with a base of e can be written as a natural log. So the natural log of 9 equals x. Okay? So like on the next one, anytime I see an e, I know I'm going to have a natural log. You can write it log base e of x equals 7, which then would translate into the natural log of x equals 7. Anytime I see an e, you can say the ln of e to the x equals 7. And then the e I don't have to write because it's like a common logarithm. It automatically has a little e down here when I use the ln. Okay? So let's go from a natural logarithm to an exponential. What is the base down here of a natural logarithm? It's e. E to the exponent 2.14 equals x. E to the x equals 18. Base, exponent, what it equals. All right, so let's just go ahead and solve some basic equations involving e's. Just like any other equation, you're trying to solve for x, you need to move everything to the other side and try and get x by itself. So the first thing I'm going to do is add 5. So 4e to the negative 2x equals 8. Well, I need to get that e to the x part by itself, so I'm going to divide by 4. e to the negative 2x equals 2. So how do I get rid of the e? This is where the natural logarithm comes in. If I take the natural log of both sides, and I just take the log of both sides. So if one side gets an ln, the other side gets an ln. And I'm using ln because my problem had this base e in it. Well, we know that using our properties, an exponent inside can come out front. Negative 2x ln of e equals ln of 2. Well, up in the rules, the biggest rule that we have about natural logarithms is that if I take the natural logarithm of itself, it equals 1. So this ln of e is going to get scratched out of my problem. So negative 2x equals the natural log of 2. To get x by itself, I could divide by negative 2. So if I go to my calculator and I take the natural log of 2 and I divide it by negative 2, I get negative 3.466 as my answer. Okay, let's try another one. 3e to the 4x minus 12 equals 15. We want to get e to the x part by itself. So I'm going to add 12. 3e to the 4x equals 27. Is the part with e by itself? No. So I'm going to divide by 3. E to the 4x equals 9. Well, how do I get x out of the exponent part? To do that, I need to take the natural log of each side. So the natural log of e to the 4x equals the natural log of 9. And what do you know about the natural log of e? It's going to drop out of your problem. So 4x equals the natural log of 9. If I divide by 4, I can go to my calculator, type in the natural log of 9, and divide it by 4. I get 0.5493. Okay. So we know e is a number, 2.71828, and it goes on and on and on forever. We know to use an e, we have to use a natural logarithm in our problem. So one of the most common things about the number e is interest problems. And I know we did problems with exponentials that said I was making interest monthly or yearly. But what happens if we accrue interest every hour of every day? It's called compounding continuously. So it's continuously compounded. It has a special formula, and that's called the PERT formula. So I have an ending amount. I always have a starting amount. But then instead of having 1 plus or 1 minus, I have e, my base e, the number 2.71828 goes on forever, to the rate times time. R is your rate, T is your time. PERT. Okay? And I use this formula anytime my problems say my interest is compounded continuously. So looking at our first example. When Angelina was born, her grandparents deposited $3,000 into a college savings account, and it was paying 4% interest compounded continuously. So right away, I know I use the PERT formula, and I know I use that because it said compounded continuously. When she was born, her grandparents deposited $3,000. So $3,000 is what I'm starting with. Into a savings account paying 4% interest. Now remember, on your rate, you have to write a percentage as a decimal. So 4% is 0.04. And if I didn't know that, I could take 4 and divide it by 100. So assuming there are no deposits or withdrawals from the account, what will be the balance after 10 years? So how much am I ending with? If I know I start with $3,000, it's compounded continuously, so I use the E. I know my rate is 4%, so 0.04, and I know I'm timesing that by 10 years. How much will we end with? So going to my calculator, I am starting with $3,000. The E button is right above the natural log button, so second in the ln button gives me e to the, and I need it to the 0.04 for my 4%, and I need to times that by 10 years. So if I don't add any money and I don't take away any money, I get $4,475.47. Okay, so the next question says you're starting with $3,000, you know you're getting 4%, but how long will it actually take that balance, the $3,000, to reach $10,000? So I know this is what I want to end with. I want to end with $10,000 if I start with $3,000. I know my rate is 4%, but this time I don't know the time. So that's why on the first page of these notes, I showed you how to solve a problem that has E in it. So how do I get this part with the E by itself? Because I need to be able to find time. So I'm going to divide by 3,000 because I need the E to get all by itself. So 10,000 divided by 3,000 is like 3.33 equals E to the 0.04 times T. Well, I know to get rid of the E out of my problem, I would need to take the natural log of both sides. The natural log of 3.33 equals the natural log of E to the 0.04 T. And when you take the natural log of itself, it cancels out of your problem. So the natural log of 3.33 equals 0.04 times T. Well, then how do you get the time by itself? I would need to divide by 0.04. So the natural log of 3.33 divided by 0.04 gives me about 30 years. So I would have to wait 30 years for my $3,000 to grow to $10,000 if I don't make any additional deposits or withdrawals from the account. Okay. Part C says if her grandparents want Angelina to have that $10,000 when she turns 18, how much would they have to invest today? So I know I want to end with $10,000. I don't know that I'm investing $3,000 because obviously it's going to take me 30 years to make the $10,000. But I need her to have $10,000 when she turns 18. So I don't know what I'm starting with. But I know the bank said I get 4% and I need that for 18 years. Okay? So how do I solve that for P? Well, if I'm trying to get P by myself and it's P times E to the 0.04 times 18, I could just divide by that. E to the 0.04 times 18. And that would tell me how much I'm starting with. So if I take my calculator and I type in 10,000 and I divide it by E, so second ln, to the 0.04 times 18 years, Angelina's grandparents would have to invest $4,867 today. $4,867.52. To not add any money to the account or withdraw. If you let it sit for 18 years, she'll have $10,000 when she turns 18. Okay, the last one says, suppose $250 is deposited into a savings account. So $250 is what I'm starting with. The interest rate is 10%. So I know 10% is my rate. And as a decimal, it's 0.110. I know it's compounded continuously, so I'm going to use the PERT formula. I want to know, when will the original deposited be doubled? So when, I'm trying to find time. I don't know my time, but I know I need it to be doubled. So if I'm starting with $250 and I need that to be doubled, I'm going to end with $500. So if I end with $500 and I started with $250, I know my rate is 10%, but I don't know my time. How long would it take $250 to get to be doubled? Let's solve it like we did part C or part B above. I'm going to divide both sides by 250. So 500 divided by 250 is 2. E to the 0.10t. Well, how do I get that exponent out of the e? I would take the natural log of both sides. The natural log of 2 equals the natural log of e to the 0.10t. And what do we know about the natural log of e? It's going to get dropped out of my problem. So solving for my time, I would divide both sides by 0.10, and then I would go to my calculator. The natural log of 2 divided by 0.10 gives me 6.93 years. So almost 7 years waiting for my money to double. But then again, that's if I don't make any additional deposits or withdrawals. If I just take money today and I let it sit there, it will keep growing, okay? All right, so hopefully you feel comfortable using the PERT formula or natural logs. Keep working on your practice pages. We will review next class, and then we have a test on this stuff. So I will see y'all later. Bye.